Hey, what's up, guys? I'm back with another video. Man, I know it's long overdue, so let's get started. Hey, first of all, we got this graph here. We got cosecant. All right, and cosecant is the reciprocal of sine. All right, so first of all, let me put sine up here on the screen. So, guys, this is the sine function, okay? This is the sine function in which, now a couple things I want to point out is, remember high, middle, low, middle. This is sine, and then I just continue with the cycle. All right, middle, high, middle, low, middle, high, middle, low. Again, high, middle, low, middle, high. So anyway, this is the sine graph, okay? Excuse me. Now, you see where there are peaks, all right? There are mount peaks, a maximum, all right? All these maximums, all right? Well, for cosecant, since it's an inverse, this is a minimum, all right? See, so that green is cosecant, all right? This is a minimum for cosecant. It's a maximum for sine, but a minimum for cosecant. Because they're inverses. All right. Again, right here, same thing. Now, even here. All right. Now, the green, all right, is cosecant. Also, you see right here for sine where that's a minimum. Well, this is a maximum for cosecant. That's a maximum. See, max, minimum for sine, maximum for cosecant. Minimum, maximum for cosecant. And here as well. All right. So now what I'm going to do is I'm going to actually get rid of the sine graph. All right. So now I took away sine. Guys, this is the cosecant graph. All right. There are some asymptotes on here, and you see, and the reason I say asymptotes is because see how these edges are unlike sine. Sine continues. Cosecant doesn't. There are asymptotes. All right. And if you remember what an asymptote is, it is an invisible line that the graph can't cross. All right. So let me put a couple asymptotes on here so you can see what I'm talking about. Let's go with a color. All right, so here's an asymptote. 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 All right. Asymptote. So now, looking at this graph, guys, I know my scale is a little off, right? Like that's pi half, that's pi. Man, that's 3 pi over 2. Let me see if I can fix my scale real quick. So here we go. I fixed my scale. All right. So now the thing I want y'all to notice is that everywhere there is a pi value, right? 3 pi, 2 pi, pi, 0 pi, negative pi, negative 2 pi, negative 3 pi. There's an asymptote, a vertical asymptote. All right. So remember, asymptote is that vertical, that invisible line that the actual graph can't cross, pass, or touch. All right. So it can't cross that. It can't touch it. All right. Nor can it pass it. Okay. Now, let's answer a couple questions about cosecant. All right. The first one is the period, okay? The period of cosecant is going to be 2 pi, all right? And because, again, remember, its inverse is sine of x. And the period of sine of x, if you remember, see that red is 2 pi. All right, that's 2 pi right there. So one cycle lasts for 2 pi. So one complete cycle of cosecant is this up and this down All right, that valley, that peak, okay? So that's one full cycle right there. Next, we have the X-Intercepts. Well, if you look back at the graph, you'll see that never touches, none of these points touch the X-axis. All right. Again, that's the X-axis. So none of those touch that X-axis, so there are no X-intercepts. And if you also look, it never touches the Y-intercept either, because the Y-intercept is an asymptote, so it never touches. Again, it never touches any of them. Cosecant never touches any axis, so there are no, none, and none. All right, and then the asymptotes. Again, one more time, let's look at it. If you see my red dotted lines right there, all right, all those values are at the n pi values. All right, and I say n because n is an integer. So any number times pi, all right, any integer times pi, there's an asymptote. All right, so let's go back and answer that question. All right, and we're going to define that. We're going to say, all right, an asymptote exists at x equals n pi for an integer n. All right, for any, let's say any integer n, for any integer n. Okay, so I can make this. So now what this does is allow us to answer questions about the cosecant graph. So right here where it says find each value by referring to the graph of the trig function or cosecant of -7 pi over 2. All right, this is saying here's an angle, -7 pi over 2. What is cosecant? So if I go back to my cosecant graph, all right, and let me pull it up so you can see the scale, right? Here it is -7 pi over 2 right here. So what value is that? Well, if you look, that's just 1 up. So the value of cosecant of -7 pi over 2 would be 1. Look, 1 up, right? So the answer there is 1. Okay. Also, right here, number 13 says find the value of theta for which each equation is true. Cosecant of theta equals -1. All right, cosecant of theta equals -1. So here it's telling us to find theta. All right, well, what theta is going to be -1? So if we go back to our cosecant graph, all right, and then you look, here's a -1. Here's a -1 on the cosecant graph. Here's a -1. Here's a -1. All right, so we needed to write a rule that defines all of those, because we're not going to say -5 pi over 2, -pi half, 3 pi over 2, 7 pi over 2. We're going to say all of them that this applies to. So there's even more. All right, there's even more. So notice how far apart these are. If you look, that's 1 pi, 2 pi apart. All these -1s are 2 pi apart. 1 pi, 2 pi. 1 pi, 2 pi. So I'm going to look at the first positive value. So you have the axis here. The first positive x value, all right, that fits the description is -3 pi over 2. Excuse me, it's 3 pi over 2. Sorry, guys, 3 pi over 2. So that's how I'm going to define this. I'm going to say any theta, or theta equals any x 3 pi over 2 plus or minus 2 pi n for any integer n. All right, any integer n. And what this does is it covers every single one. Okay, everyone in the negative direction and in the positive direction. Okay, everyone that'll give me an answer of -1. All right, now that we've done that, let's look at let's look at secant. We need to look at the secant graph. All right. One more. Goodness gracious. So here's the secant graph, okay? The secant graph, to start off, I'm going to graph cosine, all right? So let me graph cosine first. All right, so here's cosine, excuse me, guys. This is cosine, all right? So now that we have cosine graph, all right, what we're going to do is graph secant. All right, we're going to graph secant. And in doing so, remember, all right, secant is the inverse of cosine. So everywhere there's a valley for cosine, it is a peak for secant. All right. Everywhere there's a peak for cosine, it is a valley, all right, for secant. All right, and we just continue that. And just like cosecant graph, guys, where there is or there are asymptotes on here that this graph cannot cross. All right, which I want to draw them in a second so y'all can see them. All right, again, where there's a valley of cosine, it is a peak for secant. Okay, so all right, and now let me add the asymptotes on there. We'll use that line right there, and we'll make them. Alright, so asymptote can't cross that line. You'll see the asymptote like that. Now again, those asymptotes are invisible, guys. Alright, I just drew them on there just so you can see it. Okay, they can't cross those lines. Alright, now what I'm going to do is erase cosine out now. I'm going to take cosine out. Alright, so away with cosine. Let's get rid of it. Because remember, that red was originally just cosine, so let me get rid of that. Alright, so there is your secant graph right there, okay? That's secant. Okay. Now, a couple things I want to point out is, look, you see right here, unlike cosecant, this one actually crosses the y-axis. See, that's the y-axis right there. Alright, so we have a y-intercept right here. Notice there are no X-intercepts as well. Okay, so let's answer a couple questions from our notes. And the period, guys, of secant is 2 pi, just like its inverse cosine. The X-intercept, there are none, because we talked about it doesn't touch the X-axis. There is a y-intercept, and you can use this one right here to see it. It's right there. Alright, right there is 0, 1. Alright, or if you look back at the original that we had. Alright, 0, 1 is the y-intercept and the asymptotes. Well, let's look and see where all the asymptotes are. Alright, so again, there's your 0, 1. Now, where are the asymptotes? Alright, the asymptotes are all pi half value. See the green lines for you? 5 pi over 2, 7 pi over 2, negative 3 pi over 2, negative pi over 2, negative 5 pi over 2, negative 7 pi over 2, and so on. So, how far apart are those? Well, that's only pi apart. Alright, that's only the distance of pi. So, what we do is, we got to define it for all values. So, we're going to say 3 pi over 2 plus or minus pi, alright, n, for any integer n. Any integer n. N just stands for number. Any countable integer I can put there. Alright, so again, the reason I'm saying 3 pi over 2 plus or minus any pi n is because when we look at this, alright, look how far apart that is. That's pi. But I use pi over 2. Did I say 3 pi over 2? I should have used pi over 2. But 3 pi over 2, it still works. Alright, pi over 2 plus pi n, or 3 pi over 2 plus or minus pi n. It's the same thing. Alright, and I'm going to change it to pi over 2n. Pi over 2. Well, I'll leave it. It's fine. It says the same thing. Alright, it's the same statement. Because this is the first one after the axis. That's why I went with, that's why it should be pi over 2. But 3 pi over 2 still works. Minus pi is still one of the asymptotes, so we're fine. Alright. So we're good right there. Or you can say pi over 2 plus or minus pi n for any integer n. You can still say that as well. So you say either one. It works. You go. So now we're going to answer questions about the secant graph. Alright, and this first one being, So right here, we got to find secant of 9 pi over 2. Well, if you remember our rule for secant, all the pi over 2's have something in common. All the n pi over 2's are asymptotes. So 9 pi over 2 is no different. Alright? It would too be an asymptote. So we're going to say undefined because asymptotes are undefined. There's no function there. There's no graph there, okay? Then it says secant of theta equals 1. Alright, where does secant theta equals 1? So we got to find a theta, alright, or an angle where it equals 1. So back to the graph I go. So here's a 1. Here's a 1. Here's a 1. Well, what do all those values have in common? Alright, this is 0. Alright, plus 2 pi. This is 0 minus 2 pi. Alright, so we're going to define that. Alright, and how we define that is, so we'll say 2 pi, and the reason we'll say 2 pi, let's say 2 pi n. Alright, because that way it accounts for any positive integer. Not positive, any even integer. Alright. Oh, we're good. 2 pi n for any integer n. Alright, again, so if I said n was 1, so that'd be 2 pi, it works. If it was 2, it'd be 4 pi. 4 pi is 1. 6 pi, 8 pi, right? If I just keep plugging in values right there, 5, it'd be 10 pi. It'd still be an even number. If I said negative 2, it'd be negative 4 pi. That works, all right? It's going to be 1. If I say negative 1, that'd be negative 2 pi, which is still 1, which we looked at. We saw that on the graph, okay? All right, so that is going to conclude secant and cosecant. I am actually going to put cotangent and tangent on another video, okay? So catch you later.